Hello, and welcome to this Chemistry World webinar. I'm Mariana Kneppers, Chemistry World Science Media Producer. In today's webinar, we will be focusing on food, specifically in the context of the newly released book, Food and Us, The Incredible Story of How Food Shapes Humanity. We will be discussing a wide range of topics, things from evolution, food production, cultivation, and food's future in terms of sustainability. Now, joining us today is author and professor of food process engineering, Seamus Higgins. And today's webinar will be a bit more of a conversation between myself and Seamus, which means we will be taking questions throughout the course of the webinar today. Seamus began his career as an electrical engineer within the food industry, working in various positions with some of the biggest food companies, including Nestle and Premier Foods, to name a few. He's currently at the Nottingham University and has been there since 2017, where he's developed a new Masters of Science program in food process engineering. He combines his passion for a more sustainable world and novel food manufacturing techniques with a new generation of process engineers at the University of Nottingham, supporting institutions and the wider society. Now, let's go ahead and get things started with Seamus's presentation. Seamus, I think we've just passed screen sharing to you, so you should be able to start that screen share. There we go, we can see your presentation. All right, I will leave you to it for now, Seamus, and I'll pop back up once you finish your presentation, and we'll have a little video for the audience as well. But yeah, we'll let you present for the meantime.
Okay, that's great. Yeah, Mariana, thanks for the introduction, and a big welcome to everybody that's out there. As per the introduction, I'm associate professor with the University of Nottingham, and of course, I'm also an associate for the Centre for Food Policy and Foresight. But the book, well, 6 years of research and a lot of work and effort. I hope you enjoy this quick overview. But we're talking about food and us, the incredible story of how food shapes humanity. And, you know, if you think about it, what comes to mind when you think about food? Or basically, how would you describe it? A basic necessity of life? An integral part of culture and evolution? Makes us feel good, doesn't it? And satisfies our hunger. And for you chemical engineers out there, CHON, the 4 basic chemical elements that make up 95% of our food. That's carbon, hydrogen, oxygen, and nitrogen. Of course, it should also fulfill our nutritional needs, and food production has become a profitable business. And I like to think on the philosophical side, and I think of food as love. You know, from the time we're born, feeding a baby is one of the first acts of love a mother bestows on her child. And growing up as children, our food and nutritional intake, or lack thereof, has a lifelong impact on how we live, for better or for worse. But also, food has defined us over millions of years. I mean, for the first 2 million years, we were just gatherers. Hunting came much later. But societies were based around small-scale, mostly egalitarian groups that traditionally relied on gathering and foraging for sustenance. They had a nomadic lifestyle and a strong emphasis on communal living and food resource sharing. And of course, we still have that today. This is a reconstruction of Lucy. I love this little picture, but it's one of our earliest human ancestors from about 3.2 million years ago. And she was named Lucy, by the way, during the dig, after the Beatles song Lucy in the Sky with Diamonds. But when we started off, our original ancestors survived on a diet of leaves, fruits, and herbs. Lucy expanded that diet, including sedges, fruits, seeds, and nuts. Then we started to gravitate towards animal-sourced foods, basically from animal kills and excess of fat-rich marrow. Meat, marrow, and fat were only modest sources in the beginning, but they later became a lot stronger as hunting took over. And of course, fire, cooking also helped tenderize meat and make plants more edible and nutritionally available. So just like our food, our bodies have basically physically evolved to match. The human brain size has now grown 3 times bigger. We've developed smaller molars and spend less time feeding when compared to apes, 5% instead of 48%. And adaptation has also led to a small intestine and a shrinkage of that large intestine to a mere 20%. As a protection towards meat-borne pathogens, the human stomach has evolved to be one of the most acidic in the animal kingdom. And of course, all of us, our palates, our stomachs, our brains, have all evolved to like various foods and tastes. However, the more recent growth of the food industry also coincides with a dramatic shift in consumer eating habits. How the globe now eats and drinks has clashed with our biology to create significant changes in body composition. So how did that happen, or how did it come about? Well, evolutionary psychology explains our present-day traits and characteristics in terms of the survival value that we developed over those 3 million years. We also inherited them from our ancestors. And these traits have survived because the genes they are linked to were selected and have remained part of our genetic heritage. In those days, it was all about survival, food, sexual selection, trust in a family grouping. It was the environment you lived in, developing fight or flight. And our limbic brain, that's what it learned to help us succeed. You know, decisions were based on senses, our 5 senses: sight, smell, taste, hearing, and touch. And that translated into perception and actions. Reward. Much easier going for a tasty treat now than worrying about a healthy body later. Who do we belong to from a family perspective? That was where trust originally started. And of course, our behavioral response living in those days were critical to our survival. Last but not least, because the future didn't exist, we lived day to day, we were relatively short-sighted. Things like what we have today with future carbon emissions, etc., they didn't worry us because, as I said, the future didn't exist. If we think of it more from the recent research, we now know that a person's genotype is their unique DNA sequence. And more specifically, that term refers to the 2 forms of alleles a person has inherited from their parents for a particular gene. A phenotype is a term used to describe the range of observable characteristics that can vary from one individual to another, as per age, gender, or environment. But I think the most important one, and the one that we're only really starting to learn about, is our microbiome. And that comprises of microbial cells that number in their trillions and reside within us. They've not only helped us to evolve, they've shaped our biology, they've also defined the success of our species. And that better understanding of our microbiome is now often referred to as the brain and the gut. It has revolutionized the knowledge of the links between digestion, mood, health, and even how you think. Scientists now refer to this little brain as the enteric nervous system, with a direct bidirectional link to one's brain. Culturally, well, the agricultural revolution dramatically changed things 10,000 years ago. I mean, before that transition, the earth was home to about 4 million people. And by the beginning of the 1st century, with the transition to agriculture, the creation of food surpluses, world population has grown to an estimated 190 million people, of approximately just 1 to 2 million foragers, mainly in Australia, Mesoamerica, and Africa remained. But of course, it changed us culturally from an egalitarian society to its antonym: elitism, religion, farm labor. The Sumerians invented the world's first currency. Think about it. That was only 3,500 years ago. And think of the way we value money today. The first mega empires also started to grow. And as I said, culturally, we started to change dramatically. In ancient Rome, Ceres was the goddess of agriculture, grain crops, and fertility, often associated with the Greek goddess Demeter. But this is where the word cereal comes from. And grain was traditionally milled by hand with a saddle stone. But in 23 BCE, Vitruvius detailed the world's first undershot water wheel for milling grain. He was honored by Da Vinci in the 15th century as Vitruvian Man. But of course, he could have also been honored as the world's first food process engineer. And of course, gods and bread, well, 14,000 years ago, the earliest flatbread actually predates the agricultural revolution by thousands of years. But with the advent of religion, it now became part and parcel of our staple diet. I mean, in Sumerian times, Linda was considered a gift from the woman goddess. If we look at monotheism, bread is mentioned 492 times in the Bible. Bread in Judaism, symbol of sustenance and freedom, and of course bread and wine, and an integral part of Christian Catholicism and the Eucharist. Let's move on a bit to the 15th century, when Christopher Columbus departed from Palos, Spain, and began his voyage. You know, Columbus's arrival killed off as much as 90% of the 40 to 100 million indigenous people. The loss is considered one of the most significant demographic disasters in human history. The cultivation of cash-rich crops in the Americas resulted in a demand for labor that was met with the abduction of forced slave labor of over 12 million Africans. And of course, before the Columbus Exchange, there were no horses, cattle, sheep, pigs in America. There were no oranges in Florida, cattle in Argentina, bananas in Ecuador, paprika in honey. The list goes on and on. But basically, the Columbian Exchange also vastly expanded the scope of production of some new and soon-to-be widespread global addictions, bringing the pleasures and consequences of tobacco, coffee, sugar, and chocolate consumption to millions of people. The 18th century British Revolution, agricultural revolution, actually laid the foundations for the Industrial Revolution. The advancements increased food supply and drove population growth, doubled it to over 9 million by 1801. And this created the workforce for factories and stimulated new markets. Napoleon, on the other hand, faced a critical challenge with rotten food rations for his armies. They often suffered more casualties from malnutrition and scurvy than from battle. So he offered a 12,000 franc prize to anyone who could develop an effective method of food preservation. The prize was won by another Frenchman, Nicolas Appert, who has since become known as the father of food preservation. And in 1809, he preserved food in steel glasses. And in 1810, it was Peter Durand who patented the tin can based on Appert's work. And the first commercial canning factory was established in London in 1812. Henry Simon built the first milling plant in Manchester based on what was referred to as a gradual reduction milling system using steel rollers instead of stone. And that world's first automatic belt-driven steam power roller flour mill for McDougall Brothers was built in 1881. By the 20th century, money had solidified its status as the primary indicator of a company's progress or economic worth. When Winslow Taylor published his book, The Principles of Scientific Management, he set off a century-long quest for the balance between the numbers of people and the humanity of food production. So what is a company's purpose? Was it as per Drucker? There is only one valid definition of business purpose to create a customer, or was it more as per Milton Friedman, who in 1970 argued that the sole responsibility of businesses is basically to increase their profits? And this is where the conflict came in with the new food industry's conflict with business management theories. The rise of capitalism, service-linked industries, the industrialization of agriculture, globalization, market, trade liberalization, and a complete shift in the purpose of food processing. And by the end of the 20th century, these factors and more helped to create one of the world's largest manufacturing industries by both turnover and profit. We spoke earlier about it being better nutrition. So then one has to ask the question, how did a pharmacist cure his morphine addiction become the world's most popular soft drink, selling over 10,000 soft drinks every second of every day globally? Alternatively, how did a pious American Seventh-day Adventist cure for, quote, heinous sin, self-pollution, or masturbation, unquote, become the most popular breakfast cereal in Ireland? Was it all about nutrition, or was it more about better marketing? I mean, in 1931, Coca-Cola reinvented Santa Claus for the world, and the Santa we know today with a white beard, rosy cheeks, and a red prophet. But was it marketing, from drink Coca-Cola to open happiness by 2009? Or was it just profit? John Pemberton, who originally invented Coca-Cola, he sold his interests in 1888 for just $2,300. Today, the company is valued at $240 billion. So when one looks at food profitability from, say, 63 to 2014, consumer staples outperformed all other industries, and food production has now been primarily developed on a commodity-driven, brand-valued, cost-driven model. 1,000 investment in 63 would now be worth over $1 million plus. Likewise, defying all Malthusian projections, the growth in food supply actually, well, put it this way, the costs of food actually decreased as population grew from 1 to 8 billion. And given the many achievements that the food industry has achieved in terms of scalability, food safety, price and taste, an abundant supply of food supply with apparent profitable success, why would we need to change it? Well, the Ellen MacArthur Foundation has put a price on our current food model. For every dollar we now spend on food, society is paying $2 in health, environmental and economic costs. If you look at the graph here, nitrogen pollution, 78% eutrophication of our waterways and runoff costs. The current food system also contributes to poverty through a complex two-way relationship where systemic inequalities lead to low incomes, high costs for healthy food, and unequal access to resources, trapping individuals in a cycle of deprivation. It carries massive land and environmental costs, using half the world's habitual land. And of course, we're also looking at biodiversity loss, 70% of the fresh water, and vast GHG emissions. On the health side, the health costs of our current system primarily driven by unhealthy dietary patterns that lead to non-communicable diseases. And these health issues, particularly in high-income countries, result in significant economic burdens from lost labor productivity and contribute to overall global hidden costs, totaling over 10 trillion annually. So if we think about it going forward, future food sustainability challenge, how do we feed 10 billion people by 2050 without using more land or without using more resources? And of course, poor performance today, the food industry is actually behind the curve. A recent Wall Street Journal on ESG metrics reckons that only one food business scored in the top 100. Our future food and drink industry will see growing pressure for environmental and sustainability performance and transparency. Likewise, our current global demand for meat products is completely unsustainable. With protein consumption projected to double between 2070 and 2050, we cannot expect to meet this demand solely with animal proteins. On the other hand, when it comes to how much protein the world really needs, if we took the protein consumed in 2020 and distributed it evenly to the expected 2050 population, there would be enough for everybody to meet that base requirement. On the health side, well, we've looked at the recent Lancet. If I can quickly show you, the energy contribution of UPFs to diets has surged globally over recent years. In the USA, it's over 60%, UK not far behind, but it's the same in countries all over. And what we're seeing more and more is the totality of evidence that's given us several plausible mechanisms explaining that chronic disease risk, multiple nutrient imbalances, overeating, increased intake of toxic compounds, and exposure to harmful additives. Ultra-processed food, it's been said that people overeat unhealthy food, they put on more weight. But Montero, who's the founder of the Nova classification, he looked at a different way of categorizing food, emphasizing how products were made. And he concluded it wasn't just the ingredients, it was the entire system, how the food was processed and how quickly we ate it. Researchers, led by Kevin Hall, investigated, and you can clearly see from that graph the difference between a diet of ultra-processed and unprocessed. From a food company perspective, the quote at the bottom there is from the British Nutritional Institute. Studies do not allow us to draw conclusions about any cause and effect relationships with ultra-processed food consumption. Just one other thing, the food industry has concentrated in recent years over creating the so-called bliss point. And unlike natural foods found in nature, they all contain a nearly equal ratio of fat and carbohydrates. I always find it fascinating that basically human breast milk is the only natural food that has that same food ratio. Breast milk contains roughly 3 to 5% fat and roughly 7% carbohydrates. One wonders, with people who are breastfed as babies, they value foods with similar constraints. The prevailing notion that improved education and awareness of the harmful effects of junk food and the advantages of a balanced diet enables individuals to take charge of their own health and escape the cycle is not a practical solution. If we look at the diagram here, and I'll try and go through it quickly for you. We're caught up in a loop with the food industry at the moment. Food production focused on high volume, low cost calories, cheap ingredients, processing, adds the bliss point, palatability, value, reduces perishability, increase in long shelf life, higher margins, expansion of easing occasions, think of crisps and all the snacks that are out there, investment in advertising, profit and growth, greater consumption, and that reinforces taste preferences, which reinforces the loop, which is basically based on our innate human preference for calorie-rich foods. So how do we break this junk food cycle going forward? Consumption will necessitate a comprehensive approach that engages all individuals, families, communities, food manufacturers, and policymakers. Okay, I'm quick and flashing through the slides here, but when we consider our global current food system and its complexity, it's clear that our food systems are integral to both our future health and the sustainability of our planet. Our very existence depends on both. The craziest thing is, from a socio-technical perspective, we already possess the skills, ingenuity, and the expertise to create and support a more sustainable food environment that benefits both society and the health of our planet. How do we make that happen?
Food has not only fueled our evolution for millions of years, but has also dictated how we live. The 20th century and the growth of our present food system has also clashed with our biology in over 3 million years of evolution. Whether these consequences are viewed from a medical or individual health perspective, much broader issues are also at stake from an environmental and future food sustainability perspective. Indisputably, our food systems matter to everyone on this planet. The book presents a fascinating journey to our food system, connecting our rich history to the present and highlighting the inspiring individuals who have shaped its evolution. It reveals how understanding our past, embracing innovative solutions, and harnessing human ingenuity can empower us to build a more sustainable and thriving food system for now and future generations.
Thanks so much, David.
So, a little bit rushed towards the end there, Mariana, but hopefully you've run through we can check some of the slides.
It was fantastic. There was a lot to cover there for sure. Before we start diving into all of those subjects, there's a lot we want to touch base on, but why don't we do a quick poll for the audience, just to test some knowledge here. So as an audience, what do you consider is the more recent cause of rising obesity levels around the world? Now, there's a lot of research out there on the subject, and the reality is there likely isn't one definitive cause, but obesity is such a complex subject and there are a variety of factors involved. But given the options here, what do you think is the most recent one contributing to this, if you had to choose one? And it looks like a lot of people are focusing on the ultra-processed foods. I think that tends to be the main theme from the book as well, isn't it? There's quite a lot to be said about, you mentioned that Kevin Hall study from the NIH. There was quite an indictment on, the role that ultra-processed food has played in our health and the public health effects of it. I think we can go ahead and end that poll. That looks like we've got, a solid 50% saying ultra-processed foods, followed by increased calorie intake and convenience foods, and everything else is pretty evenly split, with genetics being kind of at the end there. Seamus, is that what you expected of this poll? I mean, what would you say out of all?
Mariana, it's really interesting, and it's interesting that 52% are going with increased consumption of ultra-processed foods. But I think you've also got to ask yourself why. And of course, that comes back to our genetics. It comes back to our sedentary lifestyles. And it also comes back to a food industry focused on high volume, low cost and profit. So I think that probably the correct answer to that question is all 5 of them count. And that's one of our environmental sustainability problems going forward.
Yeah, absolutely. I'm going to take a moment just to focus on the kind of ultra-processed foods aspect of things, because you did mention that in your presentation. And it seems like that kind of bliss point that you mentioned, that balance between fats and carbohydrates, what is the reason why we crave those so much? Is there a biochemical basis for why we're drawn to those, particularly the sugar and the fat combinations in ultra-processed foods?
Look, I think the jury's still out on that. I think what I found fascinating with the research for the book is we're only beginning to understand that as much as we think of our body and everything else, we've got these trillions of little microscopic organisms working in our microbiome. And they're basically controlling our moods, our thoughts. They're extracting the nutrients, all of the good things that we need to actually survive as humans, okay? And I mean, some of the other elements, I mean, as I said, that combination of carbs and fats didn't exist in the 3-odd million years we were evolving. If you take sugar is relatively new. It's only within the past 300 or 400 years that we actually have table sugar. And as somebody said, I mean, we consume more sugar now in 2 weeks than our ancestors did 100 years ago in an entire year.
Yeah.
So I think
the only natural kind of source of sugar that they might find would be in fruits or honey, if you're brave enough to brave, attacking the hive.
To take on the honey hive.
High risk, yeah.
100%, Mariana. But don't forget, you also had fruits, okay? And they would have had relatively high sugar content, but of course it would have been seasonal. And, we didn't have the preservation techniques to preserve that food. So it kind of would have been a feast in autumn when those fruits were out there. But that would have been it. Sugar or sweet things were not a real part of our diet. However, it's quite possible that in our development, our genes actually recognize, no, but hold on a minute, if it's slightly sweet, there's probably vitamin C, there's probably this, there's probably all these other good things in it. So let's encourage the brain to say, let's go for it, okay? So we get dopamine release and, we get a reward for taking on that product. Of course, today, seasonality doesn't apply. And our sweet things, our sugar, our high fat carbs, and our mix of all those products in a highly palatable product, we're getting rewarded for it. And I suppose, technically speaking, we shouldn't.
Yeah, it's interesting, isn't it? I mean, it's, you mentioned in the beginning how, in evolutionarily speaking, you do crave those specific components because those were the most calorific, the most kind of energy dense calories that you could get, right? And that's what you needed for survival, because you wouldn't know what next food source would come about. Why is it that that hasn't, to us it feels like so much time has elapsed since then. I mean, thousands of years. Why do we still have that innate sense in us? Shouldn't that have evolutionarily been kind of taken out by now?
No, Mary, I mean, this is the interesting thing. If I had to define, well, I think the opening line of the book, the one thing that's constant in life is change, okay? But there's a huge difference between our physical evolution and our cultural evolution. I mean, I go back to money. I mean, think about it. Think of everything today revolves around money. Think of your loan, your salary, your the food you buy. It's all about money. But 3,500 years ago, money didn't exist. Okay. Now, from an evolutionary perspective, I joke about it in the sense that I use the expression, if Steve Earle or what's the latest good Brit singer at the moment? Ginger hair.
Ed Sheeran?
Ed Sheeran, very man. Okay. Now,
I'm proud of myself for that.
Yeah. Their recent songs over the past couple of years, they were on about their blue-eyed Galway girl.
Yeah.
Okay. But 7,000 years ago, if they were walking around Galway, they would never have found a blue-eyed girl because we all had brown eyes. Okay. It was one little change in somebody's genome that created the one blue eye, and then it transpired from there. 4,000 years ago, we couldn't drink animal milk. We were highly allergic to it. We were completely lactose intolerant. But then tribes, mostly in Northern Europe, were given that genome to enable them to drink milk, and they reckon that really helped them develop and move forward. But again, that was 4,000 years ago. Mm-hmm. Now, if you think of the food that we eat today, or if you think of modern food, and you put it into perspective, I mean, if we take that rough number of 3 million years since we learned to walk upright on 2 legs, okay? And if you think about it, we have only been farming for 0.001% of that time, okay? Wow. But if you think about it from a food perspective or an industrialized food perspective with extended shelf life, palatability and all those things, we've only been eating that since for 0.00001% of that time. And I think, okay, I'm an engineer, right? I'm not a nutritionist, I'm not a chemist, or I'm not anything else. But if you apply basic engineering principles to a problem, you have to ask the question, what has changed? And if you look at our evolution over that time, and you look at the relative shortness of the time that we've now been eating industrialized food, and that includes emulsifiers, it includes preservatives, it includes a whole load of elements that our poor microbiome has never seen or never tasted in its life before. So now these bugs are trying to figure out, well, what is this, And I mean, it's just a picture I have, They get a dose of emulsifier and I think, what's this? This is turning us all into jelly. We're not, and it's these kind of changes, I believe, that's really causing some of the problems, And I think also, I think I mentioned it there in the summary, the big food or the food industry. They're saying there's no real cause and effect, that it's not related. But when you look at the rise in obesity over the past 30, 40 years, and you look at some of the stats, I mean, in the UK, I mean, you're looking at 60% UPF diets. That rises to 80% in adolescent children. And it rises even higher in underprivileged areas. So
yeah, because it's so cheap to produce. I mean, it ends up finding its way to communities that are looking for the most affordable alternatives, and those most affordable alternatives happen to also be the ones that are the most processed as well.
Exactly, you know, and yeah, I mean, it's an interesting thing. It's an interesting angle from a food company perspective, you know, and I touched on that briefly with the slide presentation. I mean, what is a food company's role? You know, is it to provide us all with nutritious, better priced food, or is it basically solely to make a profit?
Well, that's an interesting point, because so we've actually had somebody in the audience ask the question, if we already know that, you know, processed food is not good for human health, and as you were saying, it's not good for the gut, our bodies aren't really happy when we eat it. Why are these companies still processing it? Why do they insist on using these methods? And I guess it must come down to just profit. Is that safe to assume?
Yeah. Mariana, you know, age-old story, and it's like our food system in general. It's incredibly complex, and it's evolved to be a lot more complex as we go forward. I mean, last year, I forget the name of the organization, but they actually bought some shares in Nestle and registered a point on the Nestle board for consideration that the company must now start making better, more healthy food for all. Now, the motion was defeated somewhere around 81, 82% to 9%. There was about 4 or 5 abstentions, okay? But Nestle's prime answer to it was that if we stop making certain lines that are profitable for us, we will be leaving a huge open door for our competitors to take over. So to a certain degree, the big food and big food companies are kind of caught between a rock and a hard place, because it's an incredibly competitive environment. And okay, what they're not saying in black and white is that if the industry was regulated properly and there was a level playing field for food manufacturing, that might make a big difference. But then you come back to government control, and, you know, I mean, here in the UK, I mean, probably one of the most well-researched, most presentable future plans for our food system going forward was presented by David Dimbleby 3-4 years ago. And it was a food strategy taking into consideration not just food production, looking at agriculture, fisheries, and a whole lot of other things, you know. Now, that landed on Boris Johnson's desk about 3 years ago, and his reply seemingly was, we don't want to become a nanny state. And it's been collecting dust ever since. Now, I think that's where governments, not just governments, but also when you look at, well, basically what we're doing in the Food Systems Institute and a whole lot of other researchers out there, we're saying this is the problem. How do we look to go forward from both an environmental and sustainability perspective? And I think that's where governments need to be a lot more proactive. But again, it comes back to industry, you know, and industry is incredibly well represented. I mean, food manufacture is the biggest manufacturing industry in the UK. I mean, 12,700 factories located throughout the UK, employing over 500,000 people. So obviously they have a lot of clout with government. And yeah, it's...
Now, a quick question, sorry to interrupt, but a quick question, because somebody's asked, how do we actually define ultra-processed food? I mean, what's the difference between something that's been processed and packaged versus something like Twinkies or Ho-Hos that are, you know, you can't even tell what they even came from? I mean, when does something become ultra-processed?
Yeah, look, it's a very interesting question. I mean, the Nova food concept was developed by Monteiro in Brazil. And initially when he started, he was worried about poverty and food, and he was worried about people getting healthy food. 10, 20 years on, from statistics, he discovered that the regular purchases of rice, oils, etc. were dropping, but people were still getting fatter. And he thought, no, hold on a minute, there's something wrong here. Then when he used the same stats to look at ultra-processed foods such as crisps, snacks, biscuits, minerals, soft drinks. Well, I better leave the brand out of it, but all of those things, the increase in numbers of them were increasing dramatically. So he came up with his NOVA definition, which is basically 4 categories. And yes, a lot of food science people are saying, oh no, but it's not scientific, and oh no, it's not this or it's not the other. The whole idea behind the NOVA categorization was just to give 4 simple categories. Basically, complete whole foods, unprocessed. Then the second category was more mildly processed, which would be along the lines of preservations that we've used for centuries. It doesn't affect the food. In fact, it enhances the food. The third category would be a little bit more combination of both. And then the fourth category would be increasing shelf life, extending capacity, reducing moisture, and all of those good things, which basically, well, there's a number of definitions. I mean, Chris Van Tulligen defined it as, you know, if it contains ingredients that you wouldn't find in your kitchen at home. That's one definition of it. But I think it's been compared to scientific systems. And when it comes to food, do we honestly have a scientific system? I mean, we've lived with calories for 110, 120 years. But how accurate is that? I mean, the word calorie was invented as an energy definition for raising heat in a locomotive, in a steam engine. Okay.
Yeah, wasn't the definition, I feel like my chemistry education is coming back to me. It's like the amount of energy required to heat 1 gram of water. I could completely be making it up, but I know it has something to do with a unit of water.
100%, Mariana. It's if it's a big calorie, it's to heat 1 kg by 1 degree C. And also, you know, for our chemical people out there, it also complies with the first law of thermodynamics, which is brilliant. You know, if you're talking about raising heat for a locomotion or a steam engine, but you're not. You're talking about our bodies, which are completely different things, right? And I mean, a lot of food companies, a lot of food companies at the moment, I mean, they use, and I forget the name of the guy that invented it, it's 120-year-old technology. And he categorized foods as having, you know, carbohydrates and protein 4, and then fat as 9 calories, okay? But again, how scientific is that? Because if you look at the food and FDA in America, they put that calorie count as being plus minus 20%. So do most of the regulatory authorities in Europe and the rest of the world. So I know with some of my science colleagues here at the University of Nottingham, if I said this is the way it is, plus or minus 20%, they'd laugh at me.
It's a really, really big margin of error, and it's different across the world. I mean, how do you expect people to keep up, you know, across the world if there's no systematic units to even base it off of?
And there's a load of considerations, because obviously the energy it takes to burn something in air to fit that definition is not what happens when you eat it. You know, you eat it, it's got a value, you excrete it. There's a whole load of different things that change it.
That's interesting. I think just the definitions of all of it are just, it's like you said, they aren't very standardized, but something that we're actually getting a lot of questions about. I don't want to change the subject too much, but kind of going back a bit to almost one of the more original ultra-processed foods, if you want to call it that. Bread, you mentioned bread a lot in your presentation, the significance of it. It's mentioned 400 something times across religious texts. It has a very big basis in our life, and yet some people consider it quite a processed food. Was it always that processed, or what? How did we even come across bread? I mean, you know, where did that fascination with bread even start?
Okay, Marianne, I'm going to try something. I'm hitting the share button again, but it won't let me.
Yes, I think you did have a
slide. Can the organizer allow me?
Yeah, I think if Chris can pass you, there you go. I think you have.
Okay, there we go.
Yeah, because I remember in your book you mentioned something about, is it the Chorleywood bread process? That name really stuck out to me.
Yeah, because what actually happened after the Second World War, there was a lot of money pumped into research to develop bread, to basically make it cheaper. Okay, if you look at the left there, for thousands of years, the way we made bread was traditional, okay? 4 simple ingredients. It was stone ground flour, which was basically made from whole wheat grain, a drop of water, normally hand warm, some fresh yeast, and 5 grams of salt. And that's been the recipe for thousands of years. With the Chorleywood process, they looked at how could they make it more cost effective? How could they use lower protein UK wheat as opposed to importing it from Canada? Okay, and what we've got today is, well, have a look at it there on the right-hand side. First of all wheat flour, it doesn't matter whether it's for baking or whether you buy it for home, it's now fortified with calcium, iron, niacin, which is B3 vitamin, and thiamine, which is B1. Okay, the reason that's added to the flour is when we learned how to basically mill at the turn of the last century, we got rid of all the good stuff from the wheat, which was your bran, your allurin layer, and the endosperm. And it was only in the 30s that we realized that, hold on, this is causing problems. So now it's required by law to add that fortification back into the flour. But we also use water, yeast, salt, vegetable oil, and that can mix. We use soya flour to help with the processing. And then preservatives. We use calcium propionate and emulsifiers, E481 and E472E. Now, they're lovely with the EU numbers because you can use numbers. What they actually are is as below: sodium stearoyl lactate and mono and diacetyl tartaric acid esters of mono and diglycerides. And what that does is it helps if you're making 3,000 or 5,000 loaves an hour through a system. That dough has to be consistent. You've got to be able to cut it. If you're making an 800-gram loaf, you've got to be able to cut 870-gram dough pieces to make sure that's what you get. And it's all of those things that were added to make the bread cheaper. In fact, in the book, I remember a colleague of mine, it was a colleague of mine that said, Seamus, the secret to making good bread in the UK is to make water stand up straight and look white. The Chorleywood process helped with that because it allowed an extra 3-4% of water to be added to the flour. But what a lot of people don't realize is that to get that consistency through the plant, there's a whole lot of enzymes that are also used. And they're low dosages, alpha amylase, zelanase, basically to help achieve that dough consistency, stability, and bread quality. And then also multigenic alpha amylase in combination with fungal alpha amylase, okay? But the crazy bit is that they don't have to be detailed on the packaging because they're considered as being consumed in the process. So when you get the bread out at the other end, they're not part and parcel of the process. But let's be honest, I suppose I'm speaking on behalf of microbiome single cell organisms everywhere. You know, it was far from zelanase and other amylase that we were reared on.
Yeah, it's completely different. I mean, it does make you wonder how does that affect your microbiome? And, you know, there's a lot of talk nowadays, especially when it comes to bread, of people switching to gluten-free diets. And, you know, there's varying amounts of reasons for that. But I think even within my own kind of circle of friends and family, I can count quite a number of people in the past couple of years who have been told by their doctors, try a gluten-free diet. I mean, is that something that has become, you know, an adaptation or a treatment more or less for over-processed foods? I mean, what is different when it comes to like a gluten-free diet versus a gluten diet? I mean, does that contribute?
Again, Mariana, it's another interesting question because, you know, when one speaks to the medical fraternity, they're saying roughly 1% of the population has gluten intolerance. In fact, it's very prevalent in Ireland and a few other countries. And again, that's passed down by the genes in that, okay? But now people are talking about, well, I won't say they're gluten intolerant, but they're feeling the effects of gluten intolerance after eating certain types of bread, okay? And there's a difference in that. And I think a lot of that is due to the added ingredients that have gone into it. Because at the end of the day, the moment they shift to, well, something like a sourdough or whatever, those conditions change, you know? The other thing I often say about bread, and particularly our bread here in the UK, is, you know, let's blame it on the Romans, okay? Because 2,000 years ago, the ultimate for a Roman household was to have good, pure white bread. They actually invented the filters, silk and papyrus, to clear out what the gradual reduction system does currently, okay? But what I always find ironic is that, dare I say it, as the Romans got more wealthy and as they got fatter eating this white bread, their nickname for their gladiators, who had to fight one another to the death every second or third week, was Hunderai. And that literally translates to barley eaters. So if you think of the strength in the big guys eating all the barley, and if you think of all the soft guys, well, I say guys, male and female, eating all the white stuff, I find that really ironic, you know. And today we use barley in beer, we use it in a whole load of other things. But maybe we need to start thinking about using it in bread. Yes, you're not going to get high-rise, soft, squidgy white stuff. You're going to get a bit of more mix. But certainly from a good beta-glucan, fiber content, etc., it will be far more healthy.
Of course, yeah. I mean, there's so much to talk. I mean, that makes me want to talk about fermentation and all these things. And it's worth noting that all of these subjects are covered in your book. It's very comprehensive. I've had to read myself. But as we're kind of coming to the end of the session, I wanted to move the conversation more towards future directions. You've touched on things like sustainability. How do we keep, you know, sustaining the massive I don't know how many billion people there are in the world while balancing sustainability? A very broad question for you. What role will chemistry play in achieving a circular economy for food systems? Do you have any kind of notions, ideas on that?
Yeah, I think, Mariana, and something that we've got to look at more from team effort. I don't think any one particular discipline is going to come up with the solutions. I think it's more going to be kind of a team effort. And what we need to look at is developing alternative protein sources, right? And that's alternative meats, it's insects, there's a whole load of different elements that we need to look at to help create a more sustainable system going forward. And I think...
but I know there's also talk of things like insects as a source of protein and like insect-based protein. Is that something that you explore in your book at all?
I do touch on it. I mean, it's always been there. I mean, if you go back 5,000 years, the Torah, the Jewish book, I mean, they reckon, I think they list about 14, 15 different crickets as being completely, oh, I forget the word.
Edible.
No, there's a Jewish term for fits within their religion. Kosher. Okay.
Okay, yes, of course.
Okay, so it's been around for years. It's just we haven't thought about it. And then if you look at other communities in Asia and everything else, some of those foods are considered a delicacy. Okay.
Yeah.
But
yeah, that is such a good point. It's, you know, just because, you know, typical, if you want to say westernized cultures, you know, I mean, I certainly didn't grow up eating crickets or eating different insects, but that is quite a staple in other parts of the world. I mean, that it should be highlighted that, you know, some of us are already moving on to insect protein or supplementing our diets with that.
But I mean, the other thing is, I mean, think of prawns. We all love prawns, but I mean, prawns are the undersea, underwater version of the crickets. I mean, it's just different perceptions. But I think what's fascinating now is some of the human ingenuity driving some of the changes. I think I flashed through it on the slide there, but one of my favorites at the moment is creating food from air. And that's using hydrogen, carbon dioxide, and one of these single cell microorganisms that grow every 3 hours, okay? So they're able to produce a high protein, 60, 70% food, complete with fiber, complete with all 9 amino acids. And because this happens in a bioreactor in a factory, there's no seasonality applies to it. It can happen in any geography, because it doesn't matter where it is. That food's on the market now. It's going through legislative requirements in the EU. I think it's got an American grasping, but that first factory is outputting product now. It's things like that. The other one is
like that taste like. I mean, if it's literally just it's food from the air, does it have a flavor, or would we have to make it palatable?
It has a mild umami flavor. If anybody wants to check it, have a look. The company's called Solein. Well, the product's called Solein, and the food is called Solar Foods. Just search the websites for food from air. Okay. But the other interesting one that I think is really incredible, and that's plasma technology. It's a fourth state of matter, and we're still only learning all about it. But the beauty of plasma, cold plasma technology is it's the ultimate preservative for foods going forward without additives, preserving the natural taste and vitamin content. But what's even more exciting is that it can also be used to produce nitrogen. We were going to touch on that earlier from a fertilizer perspective. I mean, all of the artificial fertilizers we produce in the world today are based on what was known as the Haber-Bosch process, and all the chemical engineers will know that. But it's high energy, it's high output, and then the artificial nitrogen causes runoffs and a whole lot of other things. Where with this cold plasma development, we can make it far more efficient and far more productive from agricultural additive perspective. So they're the things that give me great hope. There's some incredible things happening at the moment. And yeah, I mean,
it's amazing. Yeah, I do agree with you. I think the ingenuity of the scientific community is something that, you know, we hope more things like that will come to fruition. Because it is the big question. How do we sustain such a large population for the future? But when projects like that come about, it does give you a little bit of hope that, you know, that ingenuity will provide some range of solutions. Now, we had one more question I think I wanted to cover right before we end. So what message do you hope, oh, this is from Claudia. Claudia in Suffolk is asking, what message do you hope readers take away about the role food plays in shaping cultures and communities from your book?
Oh, Mariana or Claudia, that's an excellent question. You know, I'd like to think of it as being totally open, because each one of us are going to have our own different individual perspectives. And basically, that's even going to apply on our own, how we were raised, how, you know, I mean, I start the book by saying I grew up liking all the wrong stuff, Instant Mash, Angel Delight, and all of those good things. So environmental factors play a huge role. But I think what's really required out there is a clear understanding of what's actually happening. I think, unfortunately, over the years, we've had too many conflicting science arguments, you know, like fat is bad, no, we must go on to low-fat milk, we must give up butter, go for margarine, now we're back to butter, and we're back to full fat milk. And I mean, it's only 3% fat anyway, we should never have got rid of it. But it's all of those things. And I think a much better understanding. Look, one of the points I make in the book is that we've got to enable our young people to understand how to interact with our food systems so that they can start making up their own minds about longer-term environmental and sustainability aspects. And for that, we need a proper food curriculum that will enable them to make those decisions without being biased by poster ads or whatever from fast food companies.
To be able to look past the marketing and see the science behind these decisions. I think that's a very good message to focus on.
Or a clear understanding of it. I think.
Yeah, absolutely.
That's what's so critical, because in the past, and the food industry's been great at it. I mean, the sugar industry was saying, no, it's all fat. Whereas the sugar people were saying, no, it's all conflicting. But I think now if people, okay, well, we've been telling people, no, you can't eat that, and it's all your own fault, you're eating the wrong stuff. Those messages are wrong. I think if people can understand basically how our genetics, how our biology, how it all works together, then they can start making changes in their own life and from a wider picture, environmental and sustainability decisions.
Of course. Oh, that's an excellent answer, Seamus. Thank you so much. I hate to cut you off because there's so much more we can talk about, but I'm afraid that's all the time we have today. But the great news is we have a book that, well, not Seamus wrote a book all about all of these wonderful topics, and we have a discount code for you. So you can get 25% off the book using the discount code FOOD25, all capital letters, no spaces. This code is valid until the end of the day, 11:59 at night on the 31st of January next year. And we'll include all this information in our follow-up email as well. But for now, I will give a massive thank you to Seamus for taking the time to share all of his lovely knowledge and taking the time to speak about his new book. Another thank you again to my wonderful Chemistry World digital team, Chris Pink and Ben Bausler, who've been working behind the scenes, always making sure that we look and sound fantastic and that the event runs smoothly. Thank you all for joining, and we hope to see you in another Chemistry World webinar soon. I'm Mariana Kneppers, Chemistry World Science Media Producer. Thank you, and see you next time.
Bye-bye, everybody.